If you have any questions, please type them in the chat box and we'll do our best to respond either throughout the webinar or at the end that's reserved for the Q&A. Any questions not addressed in this webinar will be answered in a follow-up email. So let's get started by telling you a little bit about InCycle software. We've been around since 2002. We're a Gold ALM and also Cloud Partner. We're focused on TFS-related services such as installation and migrations, release management, and agile tool training. From the Azure perspective, we also perform services such as infrastructure setup or application migrations. These are just a few examples, but we really cover the full ALM, DevOps, and Azure-related spectrum. We have consultants across Canada and the US, so we most likely have someone in your area. Now I'd like to introduce you to our presenter, William Salazar. William has been with InCycle for a little over a year and is a senior ALM consultant. Prior to InCycle, William was a director of the ALM practice for Nudisic. For those of you not familiar with Nudisic, they are a Microsoft National Systems Integrator and Gold ISV partner, creating effective solutions based on Microsoft's technical platform. William also spent 13 years at Microsoft in their developer experience and consulting services divisions. He was an integral part in helping customers to architect complex solutions on the Microsoft platform. So over the next 45 minutes, William will be discussing hybrid IT with Azure's cloud services. So without further ado, I'd like to turn it over to William.
Thank you, Stephanie. So good morning, good evening, and good afternoon to everyone out there. Today I want to talk to you about features around Azure networking services, how do you use them, and why you would use them. We're going to be discussing various different topics, beginning with cloud connectivity. How do I or my customers connect to Azure services? We're also going to cover details around virtual networks, point-to-site VPNs, site-to-site VPNs, and the more advanced topic of express routes. We'll then follow on to the highly available services. How does Azure Network Services facilitate creating highly available applications or services? We'll then segue into IP addressing. That's very important in your network planning. We'll discuss what are virtual IPs, DIPs or dynamic IPs, PIPs or public IPs, how you can attach to those network resources, bringing in resources that are going to allow you to do network mapping on-premise. So the IP addressing is where you do a lot of that configuration from your on-premise to your cloud environment. And then lastly, we'll touch upon security and how do I control access to my network resources. So providing access control lists to individual endpoints or load balance sets, talking about multiple NICs assigned to VMs. We'll cover all the various different options that Azure offers you for securing your connectivity from on-premise to a cloud hybrid scenario. So let's talk about cloud connectivity. I'm going to touch upon 4 points. It's really all about how I connect as a customer or how I get my users to the Azure services that are being provided. The base of this connectivity is always going to be through the Azure virtual networks. So we're providing connectivity to virtual networks through point-to-site, site-to-site, or express route. So what are virtual networks? You can think of them as just extensions of your data center on-premise. It allows you to extend the enterprise network into Azure. It supports private IP addressing that you can use for your internal data center and your networks. It works on IPv4, so it's fully contained within Azure and enables secure connection. So providing this type of network is an on-ramp for migrating your existing apps and services to Azure. These virtual networks are the base platform where you're going to enable hybrid applications to span cloud as well as on-premise infrastructures. There's a lot of different connectivity options that are going to provide you reach and access from on-premise to the Azure network. So when we're talking about the virtual networks, think of it as a protected private virtual network in the cloud. You can create logical isolation to have control over your network. You can distribute applications or different nodes or subnets on multiple virtual networks. You can create subnets as well with private IP addressing on these VNets to allow you to have full control of managing your IP address ranges. Virtual networks provide stable and persistent private IP addresses that are specific to your Azure subscription. You have a couple options of either bringing in your own DNS server or using the Azure provided DNS service. You can secure virtual machines with endpoint access control lists. These IP addresses are not internet routable by their very nature. They're secure, but you can control access to these virtual networks or specific endpoints and how they're mapped with network security groups, which we'll talk towards the end of our presentation today. So I do want to remind everyone, if you have any questions, we'll have a Q&A session at the end, but you're more than welcome to enter any questions through the IM chat window, and myself or someone on my team will be able to answer that for you. So let's talk about the VNet to VNet connectivity and how you connect between virtual networks. So multi-tier applications are going to have a requirement to allow you to span across multiple data centers. So you can do this with your virtual network to virtual network connectivity. So VNet connections are always going to be done via IPsec VPN. So that's going to provide you a private link between your virtual networks. You're going to gain the ability to create some strong isolation security across your networking infrastructure. So you can see here I have multi-tier applications that I can architect with strong isolation and secure cross-tier communications. You can see here I've got US West, VNet A, US East, VNet B, and I can provide a secure network between them. Virtual networks can exist in different subscriptions. They can also exist in many different regions. This allows you to produce an application that's multi-tenant and that you can host it in Azure. One thing you do want to be aware of is if you're architecting a hybrid virtual network configuration, you want to make sure that you avoid IP addressing conflicts. So always keep that in mind. The mapping of private addresses in the cloud in Azure, as well as those that are configured on your own on-premise infrastructure. Let's talk a little bit about hybrid connectivity here. So when we talk about hybrid connectivity, you have different options. So what we're seeing here is my first option is doing a secure point-to-site connectivity. Where I would primarily benefit from that is if I were working with a small set of individuals, such as a proof of concept, or I was doing small-scale deployments, or I had the need to connect from anywhere. So point-to-site connectivity is always going to provide you an individual connection from your on-premise endpoint to your endpoint up in the cloud. You also have the option of doing secure site-to-site VPN connectivity, and that's actually where you're having your on-premise network talking to the virtual network up in Azure. And an example where that would be applicable is if you're running a small business or you have some enterprise needs, you have to do some connectivity for Azure Compute. And it supports both infrastructure as a service in the form of virtual machines or platform as a service in the form of Azure Cloud Services such as worker roles or web roles. So you have the choice here is, and the main difference to keep in mind here is that with point-to-site, I have individual connections from my on-premise location up to a specific endpoint up in Azure, which was with site-to-site, I'm actually connecting from network to network. So I have multiple users that can share one VPN tunnel connection up to my Azure endpoints. Then lastly, you have private site-to-site connectivity or express route. In case of this is where I have mission critical workloads, such as backup, disaster recovery, media solutions, and I may have a requirement to connect all my hardware. So let's talk a little bit more detail what each one of those connectivity options are. So we're talking about point-to-site VPNs. A point to keep in mind is that each connection is opened by every user consuming an IP address. So an example here is where I would have my on-premise data center. I have individuals that are sitting behind my corporate firewall, and I have a need for each one of those individuals to have a point-to-site VPN that's going to access the VPN gateway in Azure and onto my virtual network. It also gives me the capability to have those remote workers access my virtual network through the same VPN gateway. But each one of those is going to have its own connection and consuming its own IP address. So again, it's very good for small workloads, but not necessarily something that I want to do if I'm going to have a lot of users connecting up to my Azure virtual network. Site-to-site VPNs, in this case, all traffic goes through one VPN tunnel. Individuals are not getting multiple virtual connections. So again, I have the same scenario. I have individuals with computers sitting behind my corporate firewall. They all go through my route-based VPN, and that shares one VPN tunnel through a site-to-site VPN to the VPN gateway in Azure and then onto my Azure virtual network. And I can also have a hybrid solution here where I can have remote workers, right, who aren't on my corporate network that can still use point-to-site VPN and accessing my virtual network that same way. So let's talk about the virtual network VPN and the difference between that and express routing. So the two solutions, point-to-site and site-to-site that we've discussed at this point, are what we call virtual network VPN solutions. They provide IPsec VPN over the internet. So all connections are done over the public internet up to the public cloud. Some of the things to keep in mind with that type of architecture is there's greater networking costs and higher latency. Your data is going to traverse the internet to reach the public cloud, so you're going to be limited to the bandwidth of your public internet connection. If you do have the need for a more dynamic and more advanced solution, this is where express routing comes into play. So here, in this case, you're bypassing the public internet connection, and you're having a straight connection up to the Azure cloud. So it's synonymous to having the cloud on your wide area network. This avoids risk from exposure to the internet, so that's a good benefit of express route. Also avoids complexity and adds added costs, right? You're going to also benefit from lower latency, higher bandwidth, and greater availability of the connection, right? So you're not limited or dependent on that public internet connection. You're having a straight connection from your private network up to the public cloud. That's express route. We're now going to talk about how do I get highly available services for my Azure ecosystem and the services that it offers. There's a couple different options that we have. You have load balancing and traffic manager. So load balancing is going to offer several different options in Azure. And then you can think of traffic manager as an additional service that's going to provide robust load balancing, monitoring availability for your on-premise to Azure and your virtual network environment as well. So let's talk about the Azure load balance. There's a lot of misconceptions around the Azure load balance that it is a round-robin type of load balancer. It's actually a layer 4 network protocol. It uses algorithm-based load balancing similar to round robin, but this uses an internal hash algorithm to do the load balancing. Load balancing on layer 4 is going to ensure that all of the packets for a given TCP connection or a UDP messaging exchange are routed to the exact same destination. The Azure load balancer is going to distribute the load among a set of available services, or you can think of these as virtual machines, by computing a hash function on the traffic received on a given endpoint. The Azure load balancer is going to use the source IP address, your destination IP address, the protocol type, whether it's TCP or UDP, the source port, the destination port from an incoming packet to compute that hash value. The Azure load balancer is going to use this hash value to map the traffic to an available server. So again, traffic is going to come through the 443 endpoint, go through the hash algorithm, and determine the appropriate VM that the traffic will be routed to. All packets from the same TCP connection or same UDP exchange are going to be mapped to the same server in the load balance set. When the client closes and reopens the connection or starts a new session from the same source IP address, the source port is typically going to change. So this creates a new and different hash value, so there's going to be a new mapping of traffic to the available server. So whenever you disconnect as a client or you come from a different IP address, you will be sent through the load balancer to a different destination server. So what this creates is a random distribution of traffic across the members of the load balance set. So it's similar to round robin, but it uses more of this hash algorithm approach. So based on this random distribution, it's always possible to have different connections to get mapped to the same server. Let's talk about infrastructure as a service and platform as a service tenants. So platform as a service tenants are configured via the cloud services model or through the CSDEF, the service definition schema file. Infrastructure as a service tenants are always going to be configured via the management portal or via PowerShell or the Azure APIs. Okay, so platform as a service tenants will need to be done via the CSDEF file, whereas you can use the management portal or PowerShell or the Azure APIs to configure your infrastructure as a service tenants. Multiple endpoints. So each service or virtual machine can be configured to support multiple endpoints. Endpoints must have a different port and a protocol. The number of endpoints currently supported is 150 per service. So the load balancing service offers the capability to probe for the health of the various server instances, and it's going to take unhealthy server instances out of the rotation. These are done through what are known as health probes. So you have both HTTP health probes and TCP health probes. So HTTP health probes are always going to be dependent on a specific URL that the load balancer is going to monitor. With TCP health probes, they're going to be dependent on a response from a specific port. So again, it's going to monitor that and automatically take that endpoint out of the load balance set and redirect the traffic to a healthy endpoint. The Azure load balancer also offers source network address translation. So all outbound traffic originating from a service is going to be SNATed using the same virtual IP address as for incoming traffic. Let's talk a little bit about the distribution mode. So there's two types of distribution modes that are supported with the Azure load balancer. So the first one that we're looking at here is what's commonly known as the 5-tuple hash, right? So it's going to look at these 5 tuples, your source IP, your source port, your destination IP, which is going to be your cloud service VIP, your destination port or your public port, and your protocol. And it's going to go ahead and use that hash algorithm to redirect a client connection to a specific endpoint and thereby a virtual machine. Again, keep in mind, this is not round robin, but it's more of a network communication session that's sticky. You also have the ability to have a distribution mode of source IP affinity. This will be a new distribution mode. It is based off a 2-tuple hash. Your source IP and your destination IP. The good thing about this is it's selectable and configurable. So I can literally configure and select these connections to load balance to a specific DIP. Let's look at an example of a load balancer configuration. So looking at this sample load balancer configuration, let's say, for example, this is for a cloud service. We have a series of load balance ports with several virtual machines inside. On the load balance ports, all the communication are sent equally through a hash distribution model to each VM as needed. So I can see here I have HTTP 50, HTTP 10,000, all going through my load balance ports and either ending up on virtual machine 1 or virtual machine 2. I can also have individual instance endpoints. These aren't going to go through the load balancer, and these are going to be configured to go directly to a specific virtual machine. So you have choices on how you configure your endpoints. You also have choices on if they're going to participate on the load balance set or not. Another load balancing option with Azure is the internal load balancer. It's a nice capability that allows you to provide multi-tier service within a singular cloud service. The internal load balancer is going to behave exactly the same way as the Azure load balancer. It is just an additional load balancer that you can configure. One point to keep in mind is that you cannot configure the internal load balancer using the management portal. You have to manually configure using PowerShell, the API, or XPlat, or Linux or another type of platform. So again, PowerShell, API, or XPlat if you're targeting Linux. So again, this provides you the ability to have that internet-facing multi-tier services with cloud service. So you can see here I have my Azure load balancer handling traffic from my web tier, and then I have an internal load balancer that's handling traffic from my internal database tier. Another nice use of the internal load balancer is to spread and provide load balancing across multiple services. So this comes in handy because cloud services and virtual machines have specific forms of restrictions. So some larger virtual machines must be in a specific cloud service. I can't mix and match an A1, for example, and an A8 virtual machine in the same cloud service. So I can provide some form of isolation and virtual networking and connectivity by creating these multiple cloud services and using the load balancer to route between those. So again, in cases where I have to have different cloud services because of the restrictions of Azure, I'm able to use the internal load balancer to balance traffic across these different internal virtual networks or cloud services. Now let's go on to Traffic Manager. This is an important item to consider in the Azure service that's going to help you with load balancing as well as high availability. So one of the things that Traffic Manager can do, it can help you to reduce application downtime. So Traffic Manager can improve the availability of some of the important applications in your infrastructure by monitoring your Azure or external sites and services and automatically directing users to a new location anytime there's a failure. So with Traffic Manager, you can configure it for how it is monitoring. Right, so it's similar to load balancing health probes. It can detect when a service or site is not available and then reroute you to an appropriate destination. Traffic Manager also offers improved application performance and content delivery. So it's designed to make applications more responsive and improve the content delivery times by directing users to an Azure or an external location with the lowest network latency. It looks at the relative nature of where the user is and where the service is, and it's able to choose the closest service or service with the lowest amount of latency, thereby improving overall application response time. You can also distribute used traffic over multiple locations. So Traffic Manager can direct user traffic so that it can distribute it across multiple locations, such as multiple cloud services within an Azure data center or multiple Azure websites in different data centers. So Traffic Manager can use either equal or weighted load distribution. And we'll talk a little bit about that in the subsequent slides. It also works with your on-premise data center. Traffic Manager is a popular option for on-premise scenarios, including burst to cloud or migrate to cloud or failover to cloud. You can use it to upgrade or perform maintenance on your site, on your on-site data center without inconveniencing your customers. So I can limit overall perceived downtime or implement a maintenance plan from my on-premise data center. And we'll talk about how that scenario works when I get down to the example. So how does Traffic Manager work? So initially, we're going to go ahead and have our user traffic point over to our company domain name. So in the case, I have my company domain name, www.contasso.com, for example, in this diagram that I'm showing. The client request information is going to be using the company domain name, right? So the goal is to resolve a DNS name to an IP address. So again, I want to go ahead and point my user traffic to a company domain name. So then what do I do next? I then want to go ahead and route my company domain name traffic to my traffic manager domain name. So the DNS record for the company domain is always going to point to a traffic manager domain name that's going to be maintained by the Azure Traffic Manager. So commonly you're going to achieve this by using a CNAME resource record that maps the company domain name, in this case, contasso.com, to the traffic manager domain name. In this case, it's going to be contasso.trafficmanager.net. What then is going to happen is Traffic Manager is going to take your domain name and include it as part of the Traffic Manager profile. So the user's DNS server is going to send a new DNS query to the Traffic Manager domain name, which is going to be received by the Traffic Manager DNS name server. And it's going to maintain a profile there for you. Traffic Manager then is going to start processing some profile rules. So Traffic Manager uses the specified load balancing method that you've configured and the monitoring status to determine which Azure or other endpoint should service this request. So you can configure these rules, right? So you're going to say, okay, now that I'm mapping into my internal domain name and address, what are the various rules? So it's going to send a response back to, or an actual correct IP address or resolution to where the endpoint is back to the user. The redirection is going to take place automatically, and the user is always going to be redirected to the appropriate cloud service, website, or virtual machine. Finally, the endpoint domain name is going to be sent to the user. So Traffic Manager returns a CNAME record that's going to map the Traffic Manager domain name to the domain name of the endpoint. So the user's DNS server resolves the domain name to its IP address and sends it back to the user. The user then calls the endpoint directly using its IP address. That's exactly how Traffic Manager works in a nutshell. So what are some of the scenarios in detail that Traffic Manager is going to provide significant value for your organization? One of those is failover. So Traffic Manager is monitoring all the endpoints. If one of them happens to go offline for health or maintenance reasons, you may want to deploy, for example, a new version of my code. And I want to take the primary site offline, leaving standby online. I'm going to deploy my code to my primary and then let Traffic Manager know that it's offline and let it distribute load to the standby. A good scenario of this is where I can use this to perform rolling upgrades or rolling updates to my application or services and reduce downtime to almost zero or zero. So again, I'm using Traffic Manager to kind of fail over that traffic intelligently so I can do my maintenance on my on-premise data center. The next example here is the weighted or random round robin type scenario. So I can use this this type of feature to roll out some new features or capabilities. So I can push the feature out in this example to Cloud Service D, for example, give it a weight of 1, and I can increase the weighting for others. So what the weighting is going to do is going to go ahead and push traffic to the cloud services of a higher weight that are given a higher weighting. So a smaller percentage of users are actually going to see my new features, right? And that's good from an evaluation standpoint. Maybe I only want to have a small subset of users looking at what I've deployed onto that cloud service. So this allows me a real nice way to configure the weighting so that the Traffic Manager will automatically push most of the traffic to the more stable cloud services and push very minimal traffic just for the evaluation purposes to the cloud service where I have my new application, my new features. The big scenario here is around performance. So this is good if I am working in a distributed global reach or for my application or services, right? If I have an application or service that needs this global reach. So in this scenario that I have listed here, I have cloud services that are distributed across East Asia, West Europe, US East, and US West. So I have customers from all over coming in to reach those services. In this scenario, I have a customer in some West European region, and I have them leveraging their DNS server. So Traffic Manager is going to use that to detect where my customer is coming from a geographical point of view. Traffic Manager also maintains a latency table based on the IP address and ranges of what performance is like across all my cloud services and data centers. So when a request comes in for a specific service, Traffic Manager is going to evaluate based on the end user's DNS server, and it's also going to then take into account the network latency and then choose the best cloud service to respond to or connect the user to. So you can see in this example, it knows that I'm originating from West Europe, and maybe also West Europe is down to 6 milliseconds. It's able to route that traffic to that appropriate cloud service. So this is guaranteeing or driving customers to the best network connectivity possible based on where you are or where they are geographically and the current latency table that the Azure Traffic Manager is going to maintain. So it's always going to ensure that traffic gets routed based on the right combination of where you're coming from and what the current latency is across all your cloud services. So now let's move on to IP addressing and see how that works in Azure. We're going to talk about virtual IP addresses or VIPs, reserved virtual IP address or RVIP, static internal IP addressing or DIP, and public instance IP address or PIP. How does Azure addressing work? So within a cloud service, you have your virtual IP. This is going to be an internet or routable IP address that's Microsoft owned and it's randomly assigned to a cloud service. So for every cloud service you have, it has a singular virtual IP. So how do I connect that cloud service back to my virtual machines? It's going to be through a combination of your virtual IP and port that's going to be mapped to an internal IP and port. The VP is always going to be attached to the lifetime of the cloud service. Through the Azure Load Balancer and the internal Azure infrastructure, cloud services and virtual machines are always going to be assigned a DHCP lease-based private IP address. You can always specifically specify one based on adding a VM into a specific subnet or randomly assign one if the virtual machine is not assigned one into a specific subnet. So if you don't assign your virtual machine into a specific subnet, you would get a randomly assigned virtual IP address. DIPs are stable during the lifetime of a virtual machine as well. So the internal IP address are going to be stable during the life cycle of a virtual machine. It's a long-time lease. If I stop but don't shut down my virtual machine, I still maintain the IP address. But if I do shut down or deallocate the virtual machine, the next time I start it up, I get a different DIP based on how Azure wants to assign those subnets. So again, you can see here the difference between a virtual IP address and a DIP or the dynamic IP address. Let's talk about reserved IP address. Why would I want a reserved IP address? So reserved IP addresses exist for the lifetime of a subscription. If I want to use a very specific known addressable IP address, I can use a reserve and assign that reserved IP address to my cloud service. I need to maintain it because I may have DNS rules or DNS routings around that reserved virtual IP address. But I have much more control over any of the virtual IP outbound traffic. So any other routes, DNS, or type of networking services that are going to be dependent on the IP address being static are the same no matter what. So you're guaranteeing, right? So if you have the need for a static IP address, you can guarantee that with the reserved IP address. There are some constraints. Again, it's only available for virtual machines and cloud services only. You only get 20 reserved virtual IPs per subscription. You can make some special requests through the Azure support team to get more. You're going to be charged regardless of whether they're used or not. Again, the cost is nominal, but again, you're going to be charged whether you're using these reserved IP addresses or not. The next form of IP address is the static or fixed IP address. You can think of it as a static DIP or static internal. Some scenarios would be where I would want to take advantage of a static DIP address would be if I want to maintain my own DNS or domain controller, or if I want to be able to shut down or deallocate my virtual machine and guarantee that it will have the same IP address. Again, static DIP addresses are not configured through the Azure management portal. You're going to have to do that during PowerShell or API. It is much easier to assign it during the VM creation, right? So if I'm going to create my virtual machine using PowerShell or the Azure API, then I'll go ahead and assign my static DIP address at that time. So let's talk about the public instance IP. So the public instance IP is a way to assign an internet routable IP address directly to a virtual machine. You cannot request more. You get what you get with your subscription, right? There's 5 PIPs per subscription. The biggest use of this is going to be for passive STP or in scenarios where you have the need for dynamic port selection. So that concludes the IP addressing portion. We'll now move on to network security, and we'll talk about such addressable control lists on endpoints or network endpoints, ACLs, network security groups, and multiple NICs, and how all those various features can be used to provide robust network security on your Azure virtual network. So with network ACLs or access control lists, it's the ability to specify an IP address or an IP address range and grant it permission to come and speak to or connect to your virtual machines. So the default is I have no ACL. So by default, when an endpoint is created, we permit all for the endpoint. So in this case, you're seeing all traffic from all IP address ranges hitting all my virtual machines. I have the ability to permit. So when I add one or more permit ranges, I'm denying all other ranges by default. So if I permit a specific set of ranges to access my internal virtual network, I am by default denying all other ranges. So only packets from the permitted IP range will be able to communicate with my virtual machine endpoint. I can also deny. So when I add one or more deny ranges, then I am permitting all other ranges by default. So it kind of works the opposite of permit. You can also have a combination of permit and deny. So I can use a combination of permit and deny when I want to carve out a specific IP range to be permitted or denied. There's a rule order there that you can put in, and that rule order is going to have a specified precedence when I'm evaluating my ACLs, my access control list. You do have a limit of only 50 access control list rules per virtual machine endpoint. If I am assigning a network endpoint ACL to my load balancer, then all virtual machines in that load balance set will be affected. So it's going to apply. The security is going to apply to all virtual machines in that load balancer. A best practice, however, is to use what we're going to talk about next, network security groups, for virtual machines in a VNet instead of ACL. So remember, ACLs is one way to lock down your Azure infrastructure. So a better implementation is network security groups. So network security groups use a 5-tuple type of security implementation. Right? It's going to use your source IP, your source port, your destination IP, your destination port, the specific protocol, and then allow or deny to configure the security to be able to access your endpoint. So this is going to give you the ability to segment your virtual network into specific regions and to control how networks communicate to each other. So in this example here, I've got within my one virtual network, I've broken it down into specific regions or DMZs. I have one for my web proxy or my front-end subnet. I have another one for my data subnet and my back-end subnet. So you can see here, I don't allow any direct traffic to access my data subnet. And the way that my web proxy subnet accesses my data tier is through an internal load balancer that connects to my backend subnet, and then the backend subnet is allowed to talk to my data subnet. So that's an example where I'm creating a very secure infrastructure by not allowing publicly addressable addresses to reach my data subnet or a specific region in my subnet. I can associate a network security group to a virtual machine or to a subnet within a virtual network. When I'm associated with a virtual machine, the network security group applies to all the traffic that is sent and received by that virtual machine instance. When a network security group is applied to a subnet within my virtual network, it applies to all the traffic that is sent and received by all the virtual machine instances in my subnet. A virtual machine or subnet can be associated only with one network security group, but again, each network security group can contain up to 200 rules. You can have, I think, up to 100 network security groups per subscription. Some things to keep in mind when you're thinking about network security groups is that the rules contain the 5-tuple hash, which I talked about earlier. The rules are going to be stateful. This means that if there's an inbound rule that allows traffic on a specific port, a matching rule on the outbound side is not required for the packets to be able to flow to that same port. Every network security group is going to contain default rules that allow connectivity within the virtual network and outbound access to the internet. Again, you can override these default rules by user rules. And we talked a little bit about how the rules are going to mean that they have higher priority, are going to be processed before rules with larger, meaning that they have lower priority. Finally, multiple NICs. So for every virtual machine you can add one or more virtual NICs to that machine and configure them to a specific address or have access to a specific subnet in your virtual network. There are some restrictions based on the virtual machine size on how many NICs you can attach. Additionally, NICs that you assign do not have access to the VIP addresses. So the VIP address that's assigned to the default VIP is always going to be assigned to the default NIC. So again, I have a VIP address, and that's always going to be assigned to the NIC. So you can leverage network security groups and access control lists. Preferably, you want to do that. You can create a VM from the Azure VM gallery in order to take advantage of multiple NICs. And again, these multiple NICs need to be created during VM creation. So adding or removing NICs after the VM creation is not supported by Azure. Whenever you're using network security groups or ACLS, they're only going to apply to the default NIC. Another restriction is that NICs cannot forward traffic or act as a layer 3 gateway. Right, so there are some restrictions on the use of multiple NICs. So with that, we come to the conclusion. And again, I'm not sure if we have any questions that we can take at this point.
So while you're thinking of questions, I'll talk about some offers that we have. If you just want to move to the offer, there we go. So the first offer is Assessment and Roadmap with AZDPS. So with this assessment, you can assess your company's readiness to move to Azure, review context applications, networks, etc. You can also perform a high-level financial analysis of the solution, including implementation costs, TCO, and ROI analysis. Also, you can build a roadmap on how to adopt Azure or move your enterprise to Azure. The next offer is Dev and Test with Azure Jumpstart. Our in-cycle engagement model can quickly bring your organization to implementing Azure for your development and test environments. This includes setting up your Azure network. We can also provide a free presentation of this accelerator roadmap. This has been a proven way based on successful past customer experiences we've had, but depending on your dollar commitment with Azure, there might be a portion subsidized by Microsoft, and this is to be determined. And the last offer is custom training or coaching. We have predefined training or coaching sessions available with different aspects of Azure, such as how to architect your applications to take advantage of Azure, Azure networking, and many more. So please feel free to contact us about any of these offers, but again, some Microsoft dollars might be available depending on commitment. And then I also want to talk about some upcoming webinars if you're still thinking of questions. We have several coming up. And the first one was getting started with the Azure portal, which is May 11th. Then increasing delivery speed using Azure Dev Test. Continuous delivery with Visual Studio in Azure. And DevOps in Azure, the IT agility model. You can register for all of these events on our website at incyclesoftware.com/events. And if you have any questions, please contact us at info@incyclesoftware.com. Now at this time, are there any questions that we can answer? I'll give you about another 30 seconds if you want to think of any questions. Okay, so that is all the time we have. Thank you again, William, for the great presentation, and thank you to the great folks at Microsoft for supporting this webinar. So as we conclude, please follow us on Twitter at InCycleSoftware or on LinkedIn for more upcoming events, in-person and webinars that we have. And again, I want to mention that the Azure Proof of Concept is a limited time offer. So thank you again, and thank you, William.
Thank you, Stephanie. Thank you, everyone.